Today I have a joke for you that I made up for this very lesson, which involves factorials. So, Miss Wu and I went golfing together, and before every shot, she would whisper 24. After a while, I asked her, I said, why do you keep whispering 24? She said, I have a sore throat and I can't yell 4. So 4 exclamation mark is 4 factorial, which is 24. So we're going to get into that in just a second. So we've been doing a lot of the ways we can do things using tree diagrams. And I know that's your favorite way to figure that out. I'm being facetious. And when we get to a lot of choices, a lot of things to choose from, and whether we're doing how we can arrange them or just pick them as a set, it can get to really big numbers and really complicated. So we have 2 shortcuts we're going to teach you today for a certain types of problems where we're trying to figure out how we can arrange so many things or how we can choose so many things. And these are permutations and combinations. So let's say I wanted to arrange the 4 letters in Word, and we could do the tree diagram, and I'm being nice. I actually put the tree diagram in your notes, although go ahead and put in that R and WDODR. I didn't mean to have that branch blank. So how many choices do we have for our first letter? Well, we're using the word word, so I could put in W or O or R or D. So I have 4 choices. Then for the second letter, in this case, I've already used the W. So how many choices do I have? Well, I can either do O, R, or D. So I have 3 choices. Then for the next letter, let's say I did O, then I could choose R or D. And then for the last letter, if I did R, then I only have D to choose from, and I only have 1 choice. So let's go ahead and compare the product here, which is 24. By the way, that's 4 factorial. Get it? 4 exclamation mark. We'll get to that. And if I were to count all of these different ways to arrange the letters in the word word, there are 24 of them. So in a way, this is a shortcut. So the tree diagram does show 24 ways. So this is basically going back to the fundamental counting principle, which basically says you can figure out how many ways you can do the first thing times how many ways you can do the second times how many ways you can do the third. And that'll tell you how many total ways. So let's say we're going to do this again, and instead of a tree diagram, let's be smart about it and figure out the different ways we can arrange the letters in the word smart. So I can figure out how many ways there are without actually doing all the rearranging. There are 5 letters in smart, so for the first letter I have 5 choices. For the second I have 4, then 3, then 2, then 1. If I multiply all of those out, it's 120. So a factorial, which I've been hinting at, is a special product of the integer and all the positive integers before it, down to 1. It is written as a number followed by an exclamation mark. So 4 factorial would give you the 24. 5 factorial, 5 exclamation mark, gives you 120. So if we were to do 9 factorial, I'd actually have to write out 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I would get 362,880. So you can see how big our numbers are getting. And if I had to do a tree for that, that's how many branches my tree would have. So a tree diagram is great when we're dealing with the smaller numbers, and I strongly recommend it. But if you're starting to get into bigger numbers, lots of branches, you want to avoid that. So a factorial is great when I know that I'm just rearranging, 9 things or 6 things, if I'm just rearranging that set. Now, there is a way to do it on your calculator. On the TI-84, what you're going to do is you're going to put the number in first for your factorial, all right? So in this case, I would put in 9. And then I'm going to press Math, which is this button right here. And then I'm going to arrow over to PRB and either press 4 or arrow down to 4 factorial and then press Enter twice, all right? And then it's going to give you this number, 362,880. So on the TI-84, it's actually pretty easy as long as you do math, PRB, and then go factorial to calculate a factorial. It's way easier than going on your calculator and going 9 times 8 times 7 times 6, because it's really easy to make a mistake when you're doing that. All right. How many ways can you arrange 6 letters with 15 different letters to choose from? So this one's a little different. If I was just rearranging all 15 letters, I would go 15 factorial. So let's see what we end up with here. For the first letter, I still have 15 letters to choose from. So I'm starting from my maximum. Then I've used 1, and now I have 14, then 13, then 12, then 11, then 10. And if I multiply them all out, I get 3,603,600. So big answers on these kinds of problems. So how could we use factorials to do this more quickly on the calculator? Well, on this one, it's not too horrible, but there is a way to do this with factorials. It looks like I'm trying to do 15 factorial, right? So if I were to write that out, 15 factorial, what's the problem? I have extra numbers. I don't want 9, 8, 7, 6, 5, 4, 3, 2, 1. So if I put it on bottom, those are going to go away. And so I just put that as a factorial because this is 9 factorial on bottom. So the number of ways to arrange 6 letters from 15 is 15 factorial over 9 factorial. Well, where did 9 come from? Oh, 9 is 15 minus 6. So this leads us to a formula for permutation. So permutations represent the number of ways you can arrange n items with a total of r choices to make. By the way, depending on your calculator, your software, if you're doing WebAssign, you're either going to, it's always n for the first thing, but it could be r, it could be x, and I've seen k as well. And all of those are fine. So you might not always see r, okay? Now in our example, n is like 15 and r is like 6. So this gives us this formula for permutations. It looks like this, NPR, P stands for permutations, and then you have n factorial all over n minus r factorial. Well, luckily, you can, if you know how to do factorials, you can just go divide the 2 factorials. But your calculator will also do permutations. So how do we do it on the TI-84 permutation? Well, first of all, we're going to enter our number in for n. In this case, we're going to put 15. Then we're going to press math again, and we're still going to PRB like we did before. This time, we are going to go to 2 NPR. So if you press 2, or if you scroll down here and press enter, and then you have to put in the number for R, in this case 6, and then press enter, all right? Now, by the way, you may see X instead of R in problems, and sometimes you can even see K, just to remind you of that. Now, again, you notice these are really large numbers. So sometimes we'll get something in exponential notation. So what does the E mean? So here I did 25, choose 14. And I got 3.885885,152 e to the 17. Well, there are not only 3 ways to arrange 14 things out of 25. Remember, the numbers get big. So this shows us the numbers getting really big. Basically, this is a form of scientific notation where you have a number between 1 and 10, so not all the way to 10, almost to 10, times 10 to some exponent. So E, the number after E, in this case 17, is the exponent or power of 10. And what that means is you're going to move the decimal place 17 places to the right. If you run out of digits, you just put in zeros till you get enough digits. So this is the same as this. And you can see I show all 17 places that the decimal has moved from right here all the way to there. So let's go ahead and do some examples. How many different 5-digit numbers can you create from the number 987,654,321. All right, so the point here is I have 9 different digits to choose from, all right? And I want to pick 5. So I could do, well, I have 9 choices for the first digit, 8 times 7 times 6 times 5. And I could multiply that all in my calculator. All right, It's very important that you figure out what 9 is and what n is and what r is. In this case, n is 5, and n is 9 and r is 5. So doing permutations, 9, choose 5 for permutations. We have 9 factorial over 9 minus 5 factorial, or 15,120. How many different 4-letter arrangements can you make from ambidextrous? Well, ambidextrous has 12 different letters, all right? And so n is 12, and we're choosing 4. So we're going to go 12p4, and we have 12 factorial, really over 8 factorial, which is 11,880. Now, let's go ahead and look at a twist on this. So we've been looking at permutations so far. Now we have Braden, Ellie, Michael, and Zach are all applying for 2 lifeguard positions at the YMCA. How many different ways can they pick lifeguards? Well, you could say, well, I've got 4 people to choose from, and I'm going to pick 2. So you might be tempted to do 4 permutation with 2. All right. Well, let's go ahead and take a look and actually list this out. And the numbers are not too big, so we can do this by hand. We could pick Braden and Ellie, or Braden and Michael, or Braden and Zach. Or we could pick Ellie and Braden, Ellie and Michael, Ellie and Zach. Or we could pick Michael and Braden, Michael and Ellie, Michael and Zach. Or Zach and Braden, Zach and Ellie, and Zach and Michael. All right. Does it really matter if I pick Braden before Ellie or Ellie before Braden? Aren't these 2 the same since they're the same position of lifeguard? Yes, they are. So the positions are the same, so it doesn't matter if I pick Braden then Ellie or Ellie then Braden. So I'm double counting here, so I'm going to cross that one off. Well, what other ones are double counted? Well, I have Braden and Michael, but I also have Michael and Braden. I have Ellie and Michael, and Michael and Ellie, that's the same. That one's new. And then I go, oh, I already have Braden and Zach. And then Ellie and Zach I already have, and Michael and Zach. So I've really left with only 6 different ways. But if I did the permutation formula, I would get 12 instead of 6. So what's going on? Well, there are 2 times, if I pick Braden and Ellie, how many different orders can I pick them in? I can either pick Braden then Ellie or Ellie then Braden. So there are 2 ways because there's 2 choices for the first person and 1 choice for the second. So that's going to increase my count for permutations, but I actually need to decrease the count, divide it, because this is 2 times too big because order doesn't matter. Permutations gives us an order matters answer. It gives us all 12 of these. But we're getting into combinations where we're like, oh, Braden and Ellie is the same as Ellie and Braden. So that's what we want to do. If we divide out by that 2 factorial, that fixes it and gives us the right answer. So first of all, before I give you the formula for combinations, let's go ahead and take a look at some problems. So in permutations, order matters. It does not matter for combinations. So let's see if these are permutation or combination problems. Drawing 5 cards from a deck. If you're playing poker, you can rearrange. It doesn't matter if you're getting all 5 cards at the same time, which order you got them in. All right, so we're going to say that's a combination. If you're picking the batting order, just right there, that's order matters. So that's permutation. Now, one way I keep them straight is permutation starts with the P. And I say, position matters. That's like order. So that's how I can keep track the difference between permutation and combination. Picking officers for a club. Well, president's different than vice president, which is different than secretary. So that's definitely position matters. So that's a permutation. Picking flowers for a bouquet. Well, if you're just grabbing the flowers and you haven't arranged yet, it's not really about position. It's a combination. Picking 2 books to pack in your luggage for a trip. Unless you're deciding the order by the way you pack them, which you're not, then I would say it's a combination. It doesn't matter which order you pick the books in because they're both going to go in the luggage and they'll both be there when you get there. Seating assignments. Oh, position definitely matters on that. Numbers on a lottery ticket. That one could go either way. It depends on the lottery ticket. So some of them actually the order does matter and some of them it doesn't. So like the old-fashioned lotto was a combination. You just had to get the correct set of numbers out of the 50. Picking members of a committee. So if you're on the committee, you're at the same level as everybody else on the committee. So it doesn't matter if you're picked second or third. That's a combination. If you're picking 3 winners, let's say I was giving bags of Cheetos in my class, and I was drawing 3 names, you don't care if you're picked first, second, or third as long as you're in those 3. So that's combination. And then obviously picking first, second, and third place position matters. So that's a permutation. Since order doesn't matter in combination problems, how do we adjust it? We just divide out, we add in this r factorial. All right. So calculate the number of ways you can pick 5 cards from a deck. So n is 52 and r is 5. So I would go 52 factorial over 52 minus 5 factorial, 5 factorial, which is 2,598,960. Calculate, so this is a combination because we're doing 5 cards in a deck and order doesn't matter, so I'm doing combination, not permutation. Calculate the number of ways you can pick 3 free apps from a choice of 10 apps. You don't really care what order you installed them. I'm sure you don't remember what order you installed all your apps on your phone in. So it's just as long as you get those 3 apps. So order doesn't matter. It's a combination. We have 10 to choose from. We're taking 3. So it's 10C3. And that gives us 120 different ways. Now you're probably going, it's a pain in the butt to do 52 factorial because it's such a big number. And that's true. So there is a shortcut to do these on the calculator. So to do combinations on the TI-84, first of all, you enter in your number for n. In this case, it would be 10. Then you press math like we did before and scroll over to PRB. Then you're going to press 3, which is for that NCR right here, and then enter in the number for R. In this case, it just happens to be 3, okay? And then you press enter and it spits out your answer. Now, some of you may be saying, well, I have to calculate these permutations and combinations, but I don't have a TI-84. And you're trying to work on your homework. No problem, we've got some alternatives for you. So, if you're using ClassPad, which we have in our class, go ahead and you go to ClassPad.net. It's free if you're doing the basic operations. They charge you for this extra tab right there. Anything that's grayed out, they charge for. All right, so click on a new paper to get the pop-up like we've done before. And then you're going to click on Calculate, which has this square root symbol here. All right. Then you're going to click on the Math tab on the left. So initially it's going to be on number. You have to click on Math. Then click on 2 up here. And if you're doing permutations, click on that one. If you're doing combinations, you click on that one. Then you enter in your n with a comma. So you're going to have to put the comma in here. And then your r. And then you press this execute button. By the way, if you want to do factorials, you can also do those here. So you type in the number, and then you're going to press this exclamation mark, and then press execute, and that will give it to you. But I do have another alternative for you strictly for permutations and combinations. Now this is a nice applet created on Geogebra by Heather Pierce. Haven't met her, but I found it on the internet. And what it does is it does permutations and combinations at the same time. So this is awesome. I'm going to go ahead and remember, first of all, as I adjust the slider, that makes my allowed values for K. It also adjusts. And notice if I roll n down, what happens to my maximum value for K? So n always has to be the largest number we're working with, because that's the number we have to choose from. So I'll go ahead and put in 9 and 5, which is one of the problems we worked with. Notice it uses K instead of R or X. K and R and X are the same thing for all of these problems. So here you see that the permutations is 9 factorial over 9 minus 5 factorial, or 15,120. Here, the combinations are 126. So when order matters, there are more ways to arrange things than when order doesn't. Let's go ahead and do the poker hand problems. Oh, actually I can't because that's 52. But I did do a combination with 25 and K being 14. All right, that was when I was showing you scientific notation. And here you can see, because it actually shows more digits, you can actually see the entire number on this applet. And there should be 17 places. There's 3, 6, 9, 12, 15, 16, 17. So you can see that there, when we got that exponent of 17 on 10, that made sense. Now, an interesting thing, the combinations you can see are much lower. And here's the weird part about combinations. So let me say I put K at 1. K is at 0. We pick nothing. There's only one way to pick nothing. Then we pick 1, and they look kind of the same, right? Then we pick 2, and the numbers start growing, and they grow faster for permutations than they do for combinations, which makes sense because order matters for permutations, but not combinations. But here's an interesting thing. When I get about halfway through, combinations is going to max out, and now it's going to start going down again. Because when you say, I'm going to have 25 and I pick 21, the equivalent to that is saying I have 25 and I'm not going to pick 4. How many different ways can I pick 4? So here you see 12,650. Let me change this to 4. And almost there. Oh my goodness, it's the same number. So combinations starts low and then peaks out towards the middle, right? And you can see 12 and 13 work the same way. Why? That it didn't change for 12 and 13 because I can either pick 12 things to keep or 12 things not to keep, and it works out the same way. Isn't that cool? So again, if you are looking for another source to calculate combinations and permutations and you don't have a calculator handy, as long as n is less than 25, this little applet will do it for you.